Welcome. Today we are going to learn about volume flow rate, which is also called discharge, and the mass flow rate. So we can characterize the rate of flow is as a volume. It can be a volume flow rate or mass flow rate. So today we are going to see that what is volume flow rate and how we can transform into mass flow rate. So let's have a look on the volume flow rate. Flow rate is also said as discharge. So it is the ratio of the volume of the fluid that passes across a specific area in a given time, which means that you have a certain volume in cubic meter, and when you divide it by interval of time through which this volume of fluid is passing by gives you the volumetric flow rate. So this is one of the way to calculate the volumetric flow rate. However, if you don't have the volume of the fluid, then how can you calculate your volumetric flow rate? So if you don't have the volume of the fluid, then you can use second equation, which is Q is equals to V into A, where V is the velocity of the fluid and A is the area, cross-sectional area through which the fluid is flowing. So how can it be the same as volumetric flow rate? We can look at their units. Velocity is meter per second, and when you multiply this with area meter square through which the fluid is passing at a certain velocity, it gives you cubic meter per second, right? So which is the unit of the volumetric flow rate. So then we can say either we should have volume of the fluid and time interval through which it is passing by, or we should have velocity of the fluid and the cross-sectional area through which the fluid is passing. Then in either in this case or in this case, we can calculate discharge of the fluid. Then comes the mass flow rate. So mass flow rate is the ratio of the mass of the fluid that passed across specific area in a given time delta t. So if you see here, mass is kilogram of any fluid, right, divided by time interval gives you the mass flow rate. Now what if you don't have the mass and you need to calculate the mass flow rate, but you have either the velocity of the fluid and the cross-sectional area through which it is passing by, right, and then the density of the fluid, or you already have calculated the volumetric flow rate of the fluid and you want to change it into mass flow rate because you don't know the mass of the fluid which is passing through a cross-sectional area in time interval t. So then easy thing is just divide by density, multiply by density. So what is the benefit of multiplying the density with the volumetric flow rate? So from our basic knowledge, we know that density is kilograms per cubic meter. Why? Because it is mass over volume, right? So once we multiply any volumetric flow rate, what we are doing, we can look at here. So let's take this first example and try to derive the units for this one. So it gives you density kilogram per cubic meter, and then volumetric flow rate is cubic meter per second. And if you cut this cubic meter with this cubic meter, you get kilogram per second, which is the unit for the mass flow rate. Now let's have a look on this second relationship. If you are given density of the fluid, right, and you don't know the volumetric flow rate, but you know the velocity of the fluid, meter per second, and also you know the cross-sectional area through which the fluid is flowing, then if you see these units, just cut cubic meter with this square meter and meter, you are left with kilogram per second, which is again the unit for the mass flow rate. So now let's have a look on this some numericals in order to understand how can we calculate mass flow rate and the volumetric flow rate. So we have a pipe through which air that has a mass density of 1.24 kilogram per cubic meter flows in a pipe with a diameter of 30 centimeters. So the diameter is given, which is 30 centimeter at the mass flow rate of 3 kilogram per second. So the fluid air is flowing at 3 kilogram per second, right? What are the mean velocity? What are the mean velocity and discharge in this pipe? So what we have to find out, we need velocity of the fluid, right? Of the fluid, which is air, and we need Q, right, of the fluid, right? We need both of them. So if we see here, we have given mass flow rate. So we should remember the units for discharge. What is that? Cubic meter per second. Then we must also remember velocity unit, which is meter per second. And if we notice here, we have given by the density of the fluid. So if, and also we are given with the mass flow rate, which is 3 kilogram per second. So let's have a look on the equation we are going to use, so if we see here, we can obtain the volumetric flow rate if we divide the mass flow rate of this air by the mass flow rate of the air by the density of the air. So what will happen when we will divide 3 kilogram per second will be divided by density of water 1.2, sorry, density of air 1.24 kilogram per cubic meter. So if you see here, kilogram cut by kilogram, and you will be given the volumetric flow rate as 2.2.2.42 cubic meter per second, because we divided 3 kilogram per second by 1 over 1.24 kilogram per cubic meter. So this cubic meter will come upside, kilogram will cancel kilogram, and you will get cubic meter per second of the volumetric flow rate. Now once you know the volumetric flow rate, it is very easy to calculate the velocity. Why? Because we know that Q is equals to V into A, right? And now we have to find V. So what will happen? V will give us Q over A, right? Which means that in terms of unit, we are dividing cubic meter per second with meter square. So this will cut with this, and we will be left with the velocity of the air passing through this pipe of diameter 30 centimeters. So dia 30 centimeter will be equal to 0.03 meters. So if we see here, by applying these values, we will get our volumetric velocity of the fluid. So what is the volumetric flow rate? 2.42 cubic meter per second divided by area, and the area is pi by, you can say pi by 4 d square, which is 0.03 square, gives you, and here will come meter square because you are taking square of the dia. This will cut with this cubic meter and you get velocity of the fluid. So this is how to calculate the velocity in the pipe. So then if the fluid is flowing in a channel, so if you see a rectangular channel is given, so water is flowing, water flows in a rectangular channel that has a slope of 30 degree. So now water is flowing at an angle of 30 degree with the x-axis. So if this is x-axis and this is your y-axis, so if you see here, the angle is 30-degree slope, right? So if the velocity is assumed to be constant, so velocity is constant, which is 12 meter per second. If the depth of of 60 centimeter is measured along the vertical line, so depth is 60 centimeters. So if you see this one from here to here is 60 centimeters along a vertical line. What is the discharge? They need to know the discharge Q per meter width of the channel. Per meter width of the channel, yani meaning that the the width of channel is 1 meter per meter of the channel. So we need to measure the volumetric flow rate. So you see here, I mean, this is another figure to just to give you a good look of how much is the uh, slope of this flowing fluid, and the depth is shown in the figure, right? So we can easily calculate the velocity. So velocity is calculated by we can easily calculate the discharge. Discharge can easily be calculated by V into A. But if you see here that the fluid is flowing in at an incline on an inclined surface, so we must need to know velocity component, which will be effective to calculate the velocity of the fluid water flowing in the channel. So that will be, so the equation will goes to, because for this v vector we will use v cos theta, and then we will put this one in here, vector v, and then area, and we will calculate our volumetric flow rate, which will come as 6.24 cubic meter per second. So now if we must not forget the units for the discharge, which is cubic meter per second. So what we are doing here, we are just inserting our velocity 12 meter per second multiplied by cos 30, right, multiply by area of the rectangular sheet. Now area here will be calculated by multiply the depth with the width. So this is in 60 centimeters, right, which in meters will turn into 0.06, and then depth is 1 meter, width is 1 meter, so you will multiply 0.06 meter multiplied by 1 meter, and then if you see here, now you have 1 meter, second meter, and the third meter, which gives you cubic meter per second per meter width of the channel. So that's how we should know that how can we calculate the volumetric flow rate, how can we calculate the velocity, how can we calculate the mass flow rate. So for instance, if I tell you that I need to calculate the mass flow rate of this fluid right now, m naught, so how do I do that? I just need to multiply rho with q, and the rho of water is 1000 kilogram per meter at room temperature, right? So let's insert the values. 1000 kilogram per meter cube multiplied by 6.24 cubic meter per second. So this cubic meter will cancel this cubic meter, and we will get 6240 kilogram per second per meter of the channel, right? So that's how we have to be expert in order to calculate velocity, volume flow rate, and mass flow rate. So thank you. This is all.